Okay, so if they give you sine of theta is 3/7, that is giving you two sides, right? Is it giving you the opposite and the adjacent? No, which one is it giving you? Opposite and hypotenuse. I like to write them right here. Opposite, hypotenuse. Just to remind me where they are. So if sine of theta is 3/7, then they're telling me the opposite side from theta, opposite meaning over there, is 3, and the hypotenuse is 7. And then how can I get the rest of them? I will need the last side. Take a moment and see if you're good enough at the Pythagorean theorem to figure that out. Yes, the answer will be a square root, like the square root of 37 or something. Figure it out. Can you put these away, please? Thank you. Now, no calculators because you're not going to have a calculator test tomorrow. So, all right. What I would hope you would think through is, okay, normally it's this squared plus this squared equals this squared. So maybe since they gave me they didn't give me the two easy ones, I'll take this squared and subtract this squared. And it should give me the other one squared. 7 squared is 49, minus 3 squared is 9. 49 minus the 9 makes 40, and you can't just put 40, that wouldn't make any sense, would it? So what is the answer? Root 40, okay. So if it's root 40, could you reduce that further? Yes, you could. That would have been root 4 and root 10, which would be 2 root 10. That would have been a painful way to go out. Because, dang it, I did everything else right. All right, so 2 root 10. Now, would you please just do secant of theta? That'll prove to me that you generally understand how to do this stuff. Just figure out secant of theta. Well, if it were me, I'd actually rather do cosine first and then just flip it, right? So I bet a lot of you are probably calculating cosine. Cosine of this is chi is adjacent over hypotenuse. I like to write those little helper letters in. You do not have to. Cosine chi adjacent over hypotenuse. Adjacent hypotenuse. 2 root 10 over 7. 2 root 10 over 7. Then secant must be just flip that. 7 over 2 root 10. Raise your hand if you had that one right. Okay, good. So tangent and cotangent are the only co-functions that are also reciprocals of each other. Do the angles flip? No. The sides are the thing that flips. So if tangent of this would have been 3 over 2 root 10, then cotangent I'd flip the sides and make it 2 root 10 over 3. Question or comment, or yes? Oh, I see what you're saying. Okay, the question is being asked, should I simplify 7 over 2 root 10 any farther? Because 7 over 2 is 3.5. No, don't go there. Leave it as 7 over 2 root 10. Now, if this had been an 8 over 2, then absolutely you'd want to reduce it. You'd want to say, oh, 8 over 2 reduces to 4, 4 over root 10. But don't do it with a decimal, like 7 or like 3.5 over root 10. All right, moving on. This is generally how you set these all up. This could be sine, cosine, tangent, or those new ones, cosecant, secant, or cotangent. And then there's always an angle, and that's either in degrees or radians. And then there's always sides. And what if there's not two sides? Then there still is two sides. You're just not thinking hard enough. So let's say that they give you a sine of theta is equal to 1. And you're saying, but they only gave me one side. I can't draw the triangle from that. It'd be 1 over 1. All right. So now, actually, could you have a sine that would be 1 over 1? No, you couldn't. Why not? It's opposite over hypotenuse, and you can't have them be equal. Hypotenuse has got to be bigger, right? All right, so that wouldn't make any sense. But now you actually can, if you get into circle trig, you can have weird things happen, but you don't know about that yet. So for right now, you just say no, you can't do that. All right. There is a little issue of changing between degrees and radians. Are these equal or not? No, they're not. Would you please change 30 degrees to what it is by either multiplying by pi over 180 or 180 over pi? And would you please change pi over 8 to what it is in degrees? So change the first one to degrees, change the second one, first one to radians, and change this one into degrees. Nope, no calcs. This should be left as fractions that are reduced as far as you can go anyway. All right, do you get that on this one, I should be multiplying by having the degrees in the bottom so that they'll cancel? So it's pi over 180. And then 30 over 180, well, that's like 3 over 18. It's a really good trick to just chop off a 0. So it's 3 pi over 18. It would have unfortunately got it wrong, though, because it's not reduced as far as it could be. Because 3 goes into 18. Yes? Pi over 6 is the good right answer at the end. Okay. How many had pi over 6? Raise your hand if you did. Okay, good. And Mr. B in the back row, tell me what to do on this one. Why did you choose that way? Yes, and we don't need a pi around anymore, right? Okay, so this cancels, and I'll have 180 over 8. And again, you just need to fight through it as far as you can. Give me some ideas. I can't just leave it as 180 over 8. What could I do? Okay, 8 goes in here how many times? And 8 goes in there, but 8 doesn't go into 180, does it? So 8's not going to work so good. How about 2? Does 2 go into both of them? Well, that's easy. So half of 180 is... So just start by something you know you can do. 90 over 4, and then can I go even farther from that? Yeah, what's half of 190? Or sorry, 90. 45 over what? 45 over 2. And can I go any farther than that? No. So there's your answer. And that would end up being a decimal if you really wanted to know. It would be half of 45 would be 22.5. And you could do that if you can do it in your head. Just don't have a calculator, that's all. All right. Moving on. Sine of pi over 6. Wouldn't that be nicer if I said sine of 30? You can always do that. You can always just make the change quick if you'd rather see it like that. So I know that pi over 6 is 30, so I'm just going to go sine of 30. And if you didn't know in your head, you could just take time to multiply it by 180 over pi, and hopefully you'd be able to reduce that to 30. All right, so sine of 30. What's that? Well, you got to know your 30, 60, 90s and your 45, 45, 90s. If you do, you'll be able to tell me what that is. So draw me the little triangle, and hopefully you have those sides memorized on the 30, 60, 90 triangle, and then this will be a snap. All right, I would go like this, 30, 60, 90. I would make my kind of standard one right off the bat, 1, 2, square root of 3. And then I go look at this again and say, okay, now what am I doing here? I got a sine of 30. This is the 30. So sine of this is the opposite over the hypotenuse. I probably put in my little helper thingies here. Opposite is 1, hypotenuse is 2, 1 over 2. There's my answer. Don't really need those anymore. Sound like training wheels. Kind of act like I never had them. 1/2. Raise your hand if you had that one right. Okay, good. Let's make it a little harder then. Cosine of pi over 4. No help. See if you can get it. Okay, so here's what you should have done. Cosine of, first of all, that's 45 degrees. And that I knew because you could multiply, well, I just have it memorized, but you could probably go 180 over pi, and this would reduce down to 45. Okay, so then I know it's the 45, 45, 90 triangle. And that's a 1, 1, and square root of 2. And then cosine of either one of these, because they're both 45s, cosine is adjacent over hypotenuse, so that's like that over that. So the answer is 1 over root 2. Raise your hand if you had that one right. Good. And in the old days, we wouldn't have accepted that answer because it has a square root in the denominator. Just so you know, and you're going to need to know this when we get to circle trig, and I always try to tell you stuff a little bit ahead of time before we get there, so there's not as much to learn. If I had multiplied this by root 2 over root 2, that's like multiplying it by 1. But what it does is it causes the denominator to be root 4, which is actually 2. So I'd have root 2 over 2, and that's the same answer except prettier to a math teacher, because you're not supposed to have square roots in the denominator. But why do we let you do it this way? Because the what is it called? The AP class says that that's okay. Even on the AP test they allow that. So anyway, just an FYI, a lot of books will have it this way. All right. I will accept it. You can have the square roots in the denominator. All right. Do you get that these are the classic two triangles? Which one's this one? The 45. How about this one? The 30-60. All right, good. If we use those facts, we should be able to answer these, and this one's a super simple one. What is this right here? 20. Because that's the smallest side, so the biggest side is just double it. And then this one is something times this. It always has a square root of what in it? So then it's what? 10 root 3. Okay. This one's a little harder because they gave you the side that normally has a square root in it. So now you remember what to do? Take the smaller one, and it's going to be 12 over root 3. Very good. And then to get the bigger one, you just double it, so it would be 24 over root 3. Okay. This one. This one's 15, and this one's 15 root 3. Very good. Okay. How about this one? These two are the same, but that doesn't help me if I don't know what they are. They're 3, because this has to be something root 2, and the number in front is it. 3. Okay. And this one is 75, so this would be 75, and this would be... All right, you're going to be good at this section on the test. Okay, how about this? 26 over root 2, because that's what it is on a 45-degree triangle, is the root 2. Okay, moving on. Sine of pi over 3. What's that the same as asking? Pi over, have you got this memorized yet? Pi over 60. So sine, sorry, not pi over 60. Sine of 60. Sorry. That's the same question now. And so now you'd make your 30, 60, 90 triangle, right? But what if they ask you secant of pi over 3? That's like asking you secant of 60. What would you rather figure out instead of secant? Find, not sine, cosine of 60. Once I knew cosine of 60's answer, then I would do what to it? Flip it. All right. This kind, either they give you angles or they gave you sides. See, this is the sides. They gave you the sides, and they want to know the angle. This one, they gave you the sides, and they want to know the angle. I guess this is about the same kind. Okay. So this is the kind where you draw the little picture. You'd say, I just have this one memorized. I think it's 30. You guys remember that? Sine of 30 is 1/2. And if you don't have that memorized, then you'd go, okay, well, I know it's a 1 and a 2 across from this. Sine is opposite over hypotenuse. And then I could say, oh, yeah, that's this triangle. And so if it's this triangle, it must be in the 30, 60, 90. And the one that's across from the 1, that's the 30-degree angle. So the answer is 30. All right. To do the one that's cotangent, I wouldn't do the cotangent. I would just change the problem right away and say, instead of cotangent of theta is this, I'd say tangent of theta is what? Root 3. But isn't it smarter to put over 1? Why is it good to have two things? Then you have two sides. If they ever just give you one number, say they give you a 2, and put 2 over 1 because you have two sides then. You need 2 out of the 3 sides to figure out what the other side is. All right, moving on. Rotations per minute. This one's a problem that worked out if you had a 7-inch grinding wheel that's used to like sharpen knives with. how fast it would be going if you did 75 RPM. All right, and you'd need to know pi and all that stuff, but last hour they were kind of freaked out by the whole grinding wheel, me sharpening knives in my basement thing. And so I'm going to go with a different one for you. All right, we'll go with the happy tricycle wheel. All right, so would you please draw yourself a little wheel, and let's say a trike wheel. Can you picture that being like maybe one of those little back wheels on the trike being like 6 inches diameter maybe? Okay, so write down 6-inch diameter. And let's say that you're watching this kid very slowly pedaling across the backyard on the basketball court. We have one in the backyard, and that's what the main thing they used it for when they were little, is just pedaling their big wheels and stuff around on that basketball court. So I have good memories of that. So I'm picturing a little kid just slowly pulling across the backyard, and let's say that thing was going around about 30 times in a minute. It's about once every 2 seconds or so. So 30 RPMs. Then, how fast is the kid going in miles per hour? Now, you do not need to use a calculator for this. I want you to just try to set it up. 30 rot per min. That's one of the most important things, is knowing how to write that. Then you got to multiply by a bunch of stuff so that it turns into miles over hours at the end. That's how you set it up. You have one little picture that you draw. And the tire was, what did I say that with diameter was? 6-inch diameter. Okay. Now, how you approach this is you think about canceling. You ask yourself, how can I get rotations to cancel? By putting rotations down here. What do I know about rotations? One rotation, you always have one rotation. And then you think to yourself, well, what is a rotation? It's the same as the circumference. The circumference is pi times the diameter. So a circumference on this thing would be pi times 6 inches. That's the hardest part right there. You're going to be asked to set it up because you don't have a calculator. So then the next step is you cancel your rotations. Now I got inches per minute. Not good. I need to fix it. Give me one thing to go with next. So what? You can do anything you want. Just tell me something that you think should happen. 1 foot, 12 inch. All right. Now will that make something cancel? Yep, inches. Good. Now I got feet per minute. I'm a little bit closer. Give me something to do. Yes. Oh, that's something you should memorize. So I'm going to put feet down here and 1 mile, and I'll let one of your compatriots answer. Anybody know? Thank you for raising your hand back there. 5280. Memorize it. We cannot give you that number, but I have told you since the start that I've expected you to know it. So make sure you memorize it. And am I done yet? Is it miles per hour yet? No, it's miles per minute. All right. In the front row, Mr. G. What do I multiply to get rid of this minutes here? Yep, to get rid of minutes. 60 minutes, 1 hour, excellent. So the minutes canceled, and now I have miles on top, I have hours on the bottom, and that would be a right answer. You would not have to actually do all the multiplying. I would have to look through your little thingy and make sure that you had everything canceled and the right units left. Okay? All right. So, ladder in the ground. How far up can it reach? All right. So, given this one, if it's 80 degree with the ground, this is the ladder part right here. And they're trying to get up to a window so that they can, like, let's say it's a firefighter. That's a typical kind of scenario where you have to put a ladder up the side of a house. A 20-foot ladder is not going to reach up 20 feet, is it? Because it loses some of its distance because you have to, like, pull it out from the side of the house a little bit. Okay, so how high up does it reach? Set it up. This is good for you because a lot of you are going to want to know the answer as like a decimal, but you won't know that. You'll have to leave it rough because you don't have a calculator. How far up can you, that used to be a U, can, oh no, there it is, can you reach? And the ladder is 20 feet. So it's going to be less than 20, I'll tell you that, but set it up. There was a tragic one just the other day. Did you hear about the Green Beret guy? There's fire started in his house. He had 2 little kids. He got out the 2nd story window, and it was he was so hot he had to go out the window. He couldn't go back into the house. He knew his kids were in there, and so he went back in the house through his. He got out, went back in the house through the regular door, grabbed a blanket, wrapped it around himself to try to be able to handle the heat. And he went up into his kid's room, and he was overcome by the smoke and everything, and he died right by his kids. It's just awful. But he was trying to get his kids out, you know, so you can totally respect the effort. But while the books say you don't go back in, if you get out, you don't go back in. You wait for the guys with the big thick coats and the breathing masks to go back in, and you just pray that your kid is down underneath the bed breathing decent air. You know, and it's just awful, but that just happened recently. So, on that happy note, here's what you should set up. You should have said, I need to know this. That's the opposite side. So I'm going to go sine of 80 equals n over 20. Raise your hand if you set it up that way. Good. Then you got to try to get the n alone. If you left it this way, I mark it wrong because it's not solved. If you get the 20 here and here, those cancel. 20 sine 80 is a good answer. Don't expect you to know sine 80. What if it had been sine 30? Would I expect you to be able to know that? Yes, because you know what sine 30 is. That's like a whole separate problem you could do with those little triangles. Which angles are you expected to know then? 30 or 60 or 45. Those you should be able to find out. But if it's like sine of 80, you can't find it out. And so you just leave it like this. All right, let's say that it's a scenario where it's a firefighter and he really needs to be able to get up a few more feet. Think for a second. If I just slide the ladder in, I can get up a few more inches. But how can I get this thing up a few more feet? Like, you got to get it up a couple feet. What are you going to do? What? So you're standing there, and you got to be able to get up 2-3 feet higher. What are you going to do? What? Yeah, you can get, if you even push the angle all the way up to the house, like you have no angle left, and somebody that tries to hold it against the house for you, you still don't have enough. You've got to get up like 2 or 3 more feet. Put it underneath, you can't extend the ladder. It's already extended all the way. Put something underneath the ladder. I like it. So now what? What's around? You're a fireman. You're going to stack firemen up and then put the ladder on them? I don't think that would work so good. A fire truck. There you go. You back the fire truck right up to the house, and then you can put the ladder on that. Okay? So let's say that the fire truck goes up about 5 feet off the ground. Okay? So then all of a sudden you can reach up 5 feet higher. But let's change this problem just a little bit more, and then I'm going to ask you to try to draw the picture for it because it's a little more complicated, and that's what R3s are like. So let's say that you're going to back the fire truck up to the house, and you're going to squeeze out every extra inch by going to 87-degree angle. It's like almost straight up. Now how high can you reach? Figure it out. Ladder's still 20, but you're going to squeeze the angle down to 85 degrees, almost straight up and down. Sorry, 87. 87. So your answer will tell me whether you really drew the picture right or not. And a lot of people are going to forget something. 5 foot? It's like this high. It's the back of the truck. Deal with it. It's 5 feet. It might be 7 or 8. You have bigger fire truck than everybody else. It's 10 feet, whatever, but it's 5 in my world. Yes?
On top of the truck?
It is on top of the truck, yes. Okay, so here's my triangle, and the degree now is 87 degrees, and the ladder's 20, and so now you'd set up sine of 87 is opposite over hypotenuse, my little helper thingy's in there, and the opposite side, I don't know, I call it m, over the hypotenuse is 20, and how come this looks pretty much exactly like last time? But if you put that, you're wrong. You can now you have to add 5 because of the height of the truck. It was 5, I said. Now you're making me write 10. 5 feet, so I go plus 5. And notice how messy that answer looks, and it's okay because you don't have a calculator and you're going to have to leave answers messy, just like our last test where you had complicated looking things that didn't always simplify. Yes? Yep. If you did or didn't, it wouldn't hurt anything. The only thing you wouldn't want to do is go like this. If you put parentheses there, it would make you do sine of 90 something. Which just think about the height. Do you get the ladder's going to go up higher now because it's on top of a truck?
Yeah.
So it's got to be plus 5. Yes. Okay. Go back to the real world and say, okay, if it would reach this side, now I can reach 5 feet more than that because it's on the back of a truck. Yep. All right. So here is arc length. All right, so let's talk about arc length. Let's say you have a wheel on your tire of your bike that's about this big. And let's say that you are able to, you paint your tire with white paint and then you ride on it. But you don't even get one full revolution, one all the way around before your dad catches you. You're still a kid, and he knocks you off your bike so that you stop doing that to the driveway. So here's the part that had paint on it and doesn't anymore. Okay, and this part still has paint. It's got the green paint or whatever paint you had on it. All right. So now let's say that this is 300 degrees around here. Well, conversely then, how much is the part that's left? Okay. So the question might be, if this was a total of 3.5 feet, that's how long the green line was on the driveway. Get it? Because it came off of your tire and onto the driveway. Okay. If that's 3.5 feet, then how big is the radius of the tire? I'm going to say that again. You pedaled a 300-degree angle, which meant almost all the way around the circle, but not all the way. And you put a line on the driveway that was 3.5 feet long. Then what's the radius of your tire? Well, I hope you know a formula that goes along with this. What's that? SOR. S equals theta R. Now, did I give you the angle? I did give you the angle, yes. And the angle is 300 degrees, but you're supposed to use what's? You're supposed to use radians is my point. It's in degrees, you want radians, okay? So, did I give you the S, the arc length? Yes, I did. I gave you this and I gave you this. What I didn't give you is the radius. So, let's make that blue. I want R. I already have the other two. So you stick in the things that you know and try to solve it. All right, so what was the arc length? Is a big arc 3.5 feet. It's this all the way around here's part. So that goes in here. And theta, you better not use 300 or it won't work, because 300 is in degrees and you want radians. So, Mr. K, tell me how to convert that 300. There's two Mr. Ks. The one with the hat on it isn't supposed to have a hat on. Take it off. Yes. Pi over 180. Perfect. And now I have 300 pi over 180. I could probably simplify that a bit, but so I have 3.5 equals 300 pi over 180 r. Do you see how r can get alone? Just have to get r alone, so I can. How do I get rid of that nicely? Multiply by the reciprocal. Okay, so I'm going to multiply by 180 over 300 pi. So my final answer, 180 over 300 pi, it's just the flip of what it was before, times 3.5 equals r. There we go. Yep, you can leave it like that because you don't have a calculator. All right, you have one just like that on your homework. So your homework is excellent practice for the test. I looked it over and somebody did a really good job making this thing. It is, and all the answers are going to be online tonight. So this is how you study. You do this and you don't even start studying until you check it. And once you've checked it and you got a couple wrong, that's where the studying part starts. And you should spend an extra, depending on the kid. Some of you probably are straight A students and are not worried about it. You don't need to spend any more time than just checking it. But some of you guys should probably spend an extra half an hour to an hour after you've checked it, going over stuff.